Hard to believe that there's even another center of a triangle. This time we're going to see what happens when we draw medians. Now, median is a new word, and so let's define it before we get too far. For a median, what you want to do is you want to go to the midpoint of a side. So we're doing a bisector, but in a special way. We're going to go ahead and do the midpoint of a side. Go ahead and mark that with the tick marks. And rather than drawing the perpendicular bisector, the one that goes at a right angle to it, we're just going to go ahead and take that midpoint there, and we're going to connect it to the vertex that is directly opposite it. So this is going to be a segment that's going to run through the triangle, connecting the vertex to that midpoint on the opposite side, and that is what we call a median. So this segment that joins the vertex of the triangle to the midpoint of the opposite side is a median. So let's play with that definition a little bit. Here's an example where we are shown a triangle with one of its medians drawn in. So just for the practice, I want you guys to be tick marking. If they tell you this is a median, then I want you to mark that that was a midpoint by giving the tick marks on either side of point R. Now let's see what they tell us. N to M, all the way across, this whole thing is 3x. And R to M, right here, is 2x minus 1. And we get to, of course, find x. So these are clearly not equal in length, but this 2x minus 1 would be half of the total all the way across. So we can copy it again. 2x minus 1 would be here, and those combined together equal our 3x. So let's write it this way. I'm going to just say 2 multiplied by 2x minus 1, rather than write it twice, is equal to the full 3x length. So double the 2x minus 1, and I get the 3x length. Let's distribute the 2x in there. That 2 times 2x is 4x. 2 times 1 will give me a negative 2. Bring down that 3x. And then let's see, if I subtract 4x from both sides of this, I'm going to get a negative on my x value. These will cancel. I get a negative 2 left here, and I get just negative 1x. So I'll just write negative x. So just clearing out that negative, x is going to be 2 for our solution. Okay, next example. Again, we are shown a triangle with one of its medians. I want you, every time you see median, I want you to mark the equal parts around that midpoint. And let's write our information in. D to I is 2x minus 8. And D to H down here, that's x plus 2. So we get to find x. Well, what's the relationship between these? We've tick marked them as equal. That's what we're going to say they are. We're going to say 2x minus 8 equals x plus 2. Pretty straightforward. All right, solving for x. Let's take away the x from both sides here and also here. In fact, let me draw that line this time. All right, yeah, those are out of there, and I'm left over here with just an x. Okay, let's bring down that minus 8 and that 2. All right, next step, we're going to add the 8 so that we can cancel on this side. Bring it over here. Those are gone, and x is alone. X is equal to 10, and we got it. You guys can do those. Okay, next one, we've got a try this for you. So I want you to mark that median and find the value of x. Come back to me after you pause the video and check the solution. Okay, if you got x is equal to 8, you're probably good to go. Go on. If you didn't, check out the steps here. I put the information in. I've tick marked that as a median with the s as the midpoint. And it looks like I had to double this shorter segment. I needed 2 of those in order to equal the full length. So that's my setup. 2 times that x minus 1 is equal to the full length of x plus 6. And then you can check out the steps of the algebra. Hopefully that went well for you. Okay, so now we get to learn about what's known as the centroid, another center of a triangle, and this one's formed by the medians. In this triangle, I want you to mark that these points D, E, and F, these are the midpoints, so let's mark those as midpoints by marking the sides around them as matches. Remember to use double tick marks and triple tick marks to show the different matches, just like that. And then let's use a straight edge. If you don't have a straight edge, you better pause the video because this has to happen with a straight edge. And let's draw the medians in. In fact, I need to change my tool here and make sure I've got a straight edge. Okay, so the medians again, I'm going to draw from vertex A across through the triangle to the midpoint of the opposite side, which is going to be F. So AF is one of my medians. Let's come from C, this vertex, across to D, the midpoint on the other side. And then B is going to come all the way from B clear through to E on the other side. All right, what do you notice? Probably not a surprise at this point. We've seen this happen before, but all three of those medians intersect in the center. This time the centroid is what it's called. So the centroid is where they cross through each other, and they are concurrent again. Now the centroid is actually the point of balance of the triangle, so the mass of the triangle is equally distributed around that. And I want you to do an extra credit project. This is a good chance. So the next video is going to explain that, and it's going to let you explore a little bit more about how this is the center of mass or balance. But there's another thing that you want to write down here, and that is how these segments, these medians, are divided by this centroid point. And this is how it happens. You see on this CD median right here, for example, you've got a longer piece that comes from the vertex to the centroid. Then you have a shorter piece of it from the midpoint to the centroid. Well, that longer piece and shorter piece are always cut into the same ratio. And it's a 2-to-1 ratio. So what that means is this longer piece is twice the length of this shorter piece. We can write that this way. If the shorter piece is x units long, then this is going to be double that. This is going to be 2x units long. And that works for all three of our median lines. We've got our longer part coming from the vertex. That's always twice the length of the shorter part. So here on this one, for the F to this centroid point, if this is y units long, then this longer piece of that same median is going to be double that, or 2y units long. And of course that works in reverse. Say that I've got this long piece here, and that's z. Just making up some letters here. So this is z units long, and that's the long one. This one here isn't going to be double. It's going to be half of that other one. So half of z is the length of the shorter one. Let me show you how that works with some examples. This first example is a chance for us to see how we find the coordinates of the centroid. So you've got a triangle on a coordinate grid, and we're going to have to find midpoints because the centroid is made by medians. So let's start with the midpoint of AB. Let's check out where point A is. Here it is at -3, 6, or -3, -6, and point B is up here at -4, 0. So let's calculate the midpoint of that. Hopefully you know the midpoint formula. That's where we're going to average our x's and average our y's. So let's do our x average first of all. We're going to take the x average and find it to be, add those x's together and divide by 2. So let's take the -3 and add the -4. Divide that by 2. That's -7 over 2. And let's just say that's -3.5. We'll decimate it. And then our y average. Our y average is a 0 and a -6. So let's add those together. So I'm going to go with -6 plus 0. Divide that by 2 to average it. And I'm going to get -6 over 2, or -3. So the coordinates for our midpoint for AB are -3.5 and -3. Let's look at that on our graph. So I'm going to go to -3.5 and then down to -3. And I'm right here, which looks good. This will be my first midpoint for the AB segment. All right, and let's go to the midpoint of BC next. So here's BC, this long segment on our triangle. We're going to do the exact same thing again. We're just going to take averages. So our x average, let's look at the x coordinates for B and C. Looks like, let's see, I need to know, C is at 1, 6. So let me just show that on the screen. Okay, so again, our x coordinates for B and C are, looks like again, -4 and 1. Let's add them together, divide by 2. So -4 plus 1 divided by 2. -4 plus 1 is -3. -3 divided by 2 is -1.5. Now for our y average, we're going to do the same thing. Our y's are 0 and 6, so adding 6 to 0 and dividing by 2 gives me 3. So my coordinates for this midpoint are -1.5, 3. Let's see if that looks good on our graph. So -1, and there's -1.5, and then to -3. Oh, did I miss a negative somewhere? Shoot, this should have been a -6. That's my mistake. So I got to go back and fix that. So my y values are 0 and -6. And yeah, that's going to make this say -3. So let's get that fixed. Good deal. Okay, so -1.5 and -3. And that puts me right here, just like I was trying to mark before. There's my midpoint for that side. Okay, now I left the midpoint of AC out of my list over there because AC is a nice horizontal line. I can just count that, and I'm going to. So from A to C, it's 1, 2, 3, 4 units. I'm going to cut that in half and just do 2 units right here. That one's an easy one to find because of that horizontal line. All right, so those are my 3 midpoints. Now to find the coordinates of the centroid, a straight edge is important. I'm just going to connect the vertices to those midpoints. So let's make this connection here and A over to here. And there's my centroid. Just for good measure, let's connect at the last one. This is a nice check right there. So my centroid is right there. And what are the coordinates of that point? That's going to be my answer. Looks like the coordinates of that point are, if we want to read this, it looks like it's -2 and -4. Don't lose that negative. So -2, -4 would be my centroid coordinates. And label that as the centroid. Excellent. All right, now these next examples are a chance to use that property. Let me just jump back to review it. This is where we're going to say that the median is chopped into 2 pieces, not equal, but one twice as long as the other. One is twice as long as the other, those pieces. So let's look at this example. Okay, so in this first example, we have a chance to do the medians. And again, it's chopped into 2 pieces, one short, one long, with the longer one being twice the length. So let's see what we're given here. We're going to find DP. We're told that PW is 8.6. I want to write that in my picture. So this piece, PW here, is 8.6. And then our question is DP, this piece of that same median. All right, so P to W, now that comes from the centroid to the midpoint. That's the shorter piece of it. So this is going to be twice that length. So I'm going to say that DP segment is 2 times the length of the PW segment. So I'm going to go 2 times 8.6. And 2 times 8.6, if my arithmetic is right, I believe that's 17.2. If I'm wrong, I'm sure you'll let me know tomorrow. Okay, and here's a second look at that same kind of thing. We're going to find HZ. We're told that H to S is 27. We're also told that these are medians. And so we're going to be able to use that 2-to-1 relationship. But this is a little bit different because we are told that H to S is 27. And H to S is the whole thing. We aren't told anything about the pieces. But we are still going to be able to use our relationship because we know that each piece is still following that 2-to-1 ratio. So if my shorter piece here is X, then I'm going to say my longer piece is 2X. So how long would the whole thing be? I'm going to call the whole thing 3X. 3X for the whole part, the whole thing, is equal to the full length of 27. You see how that works? So that would mean that X, if I just divide by 3, that X alone would be 9. So this piece here, this shorter piece, is 9. And that makes my longer piece, 2X, that's going to be 18. And that still works in my doubling thing. And so there's my answer. H to Z is 18. I hope you see how that works, and we'll practice some more. Please do the extra credit. It's pretty easy, and it's kind of interesting how it balances that triangle. And I will talk to you tomorrow.